So we can't talk about Android without talking about life cycles. This feels like a pretty obligatory thing in our world, but I want to frame a little bit of a different conversation about life cycles. Because as software developers, it's sort of our job to make assumptions about our world. We make assumptions about what our customers need and what our product managers really want us to do. And we also make assumptions about how we can model things so that they're easy to digest. If we don't make these sort of assumptions, it's really impossible to get any meaningful code written whatsoever. The problem comes in where we make assumptions about our frameworks and about our platforms that don't hold up. Because when we do things like this, it leads to really obscure crashes and subtle bugs that you may not even know about. And I'm going to talk specifically about lifecycle related false assumptions. And depending on what sort of experience you might have, you may be hearing me talk about these and think that these are really basic assumptions that are incorrect to make. I promise that more people are making these than you would think. I work at Big Nerd Ranch, and you may think of us as more of a training company, but on a day-to-day basis, we do consulting. And we see a lot of projects that come in, and a lot of projects with a surprising number of users are making these sort of mistakes. So we're going to dig right into it, and we need to start at the very basics when you worked on your first Android application. It might have looked something like this. So here's a really basic counter application that I made. You've got an increment and a decrement button, and you can just count some number of things that are happening. And this is all great, but what you probably noticed when you were working on your first app was when you rotate the phone, this state disappears. And if you're not expecting this, this is a really confusing experience to get. So the next steps are you probably did some or all of these, but really the positive here, the best case scenario is that you end up going down the path of implementing on save instance state. You go through all the song and dance of writing that value, that counter incremented value into a bundle, restore it out, do all that song and dance. And you realize that these are a lot of steps to go through. And you realize that this is a lot of things to keep track of if you're working on some really big application. And then eventually you do start working on some really big application. And one thing that you're very likely to run into, especially if you have a designer, is they might ask you, we don't want to support landscape. That's not really something that we can design for. So can you lock the app to portrait? And when you hear this, you might have this reaction. And you may not notice that you've made an incorrect assumption here. The assumption that you've made is that the only reason that you'll lose state and the only reason that your activity restarts is because of changing from portrait to landscape. This is incorrect, but we'll talk about that more in just a second. We haven't gotten there yet. Right now, you're going into your Android manifest, you're setting the screen orientation to portrait, you're adding a lint suppression, and then there's no orientation changes anymore. So you don't have to worry about your state being lost on a configuration change. Then somebody else on your team is going to mention, well, what about multi-window? Are we doing anything to support that? And you're not really sure how this works, so you go into your Android emulator and you enter multi-window, and your state goes away. So you do some more research, and the really easy option is to turn off multi-window support. And you can do that, and it'll get you by really quickly, but you can sort of tell that it's not really the best goal. And you've made another assumption here, which is that there's a really small number of reasons that your activity can be recreated, and multi-window is just another one of them. But you still might not know this yet. So going back into your Android manifest, you set resizable activity to false, and now you don't have to worry about multi-window anymore. Then somebody like your product manager comes along and they say, well, what about that Samsung foldable phone, the really fancy and expensive one? Are we doing anything to support that? And you might not know either. So you look up and you find that you can spin up a foldable phone emulator. You run your app on the foldable phone and everything looks great so far. But then you unfold the phone and something really unexpected happens because your app still has its state, but it's got all these black borders around it. It's kept the same size that it had before. This is a compatibility mode that the system is imposing on your app because you've set resizable activity to false. And you can see that there's a banner that says you can make this app full screen, but you'll have to restart it. And if you click that button, then your state goes away, which is the exact same problem that we've been seeing over and over again. So you do some more research, and depending on where you end up, you might see a Stack Overflow thread that's guiding you to use the Android config changes property in your Android manifest. If you don't know really what's happening here, then you're actually making two assumptions here. The first assumption is that config changes is a really cheap way of properly handling configuration changes. We'll get back to this in a second. The second assumption that you're making here is that there is a way that you can reliably prevent your activity from restarting. That's what we've been seeing this whole time. Both of these are incorrect, but if you did want to make this change in your Android manifest, you can get rid of a lot of the code from before. You can add this config changes line here. Even though you're specifying a lot of things here, you no longer have any lint suppressions, which is nice. But this is overlooking a lot of details. And to dive more into this, we need to see all of the reasons that your activity can restart. So far, we've been talking about this first group, which falls into the bucket of configuration changes. And more specifically, we've been talking about these two, orientation and window size, which are sort of the same thing if you think about it from a really high level. But there's a lot of reasons that your window can resize. It's things like multi-window, it's foldable phones. If you're running on a Chrome OS device, then you can run in a window and the user can literally resize that window. But there's a lot of other types of configuration changes that your activity can restart from. A few other ones are language. So if the user changes their language, then your app will restart, or you'll get a configuration change and the activity will be recreated. You can also change the device and font scaling factor to make things on screen bigger or smaller. And the user can also change their SIM cards, and depending on which version of Android you're running on, that might also trigger a configuration change. And there's more than these. So you can add these to that Android manifest config changes property. The downside here is that really the goal of the config changes attribute in XML is you're telling the framework that you're going to handle these types of configuration changes. So if you didn't have alternative layout resources for portrait or landscape or different window sizes, you might not have noticed that something unusual was happening. But if you have translations for your application and you put language inside of config changes, you'll notice that when the user changes their language, all of the text inside of your application will still be in the old language and locale. So it won't be until you fetch resources again that you start seeing things in the updated language. And really, you're supposed to go through and manually set those strings yourself, which is very complicated, and that's why this isn't recommended. And you're supposed to do that for the other types of configuration changes as well. There's also night mode, which is a little bit of an outlier here. Night mode is special because it's implemented a little bit by the framework and a little bit by the support library. And with night mode in particular, there isn't a way to add it to the config changes property. It's not a supported value. So if you do want to support night mode and you do want to use the constructs that the platform has provided to you, you don't really have a choice. You have to support configuration changes. And the really recommended way that you do that is to use ViewModel. And at this point, you're probably talking your platform lead into doing this. And if you're using ViewModel, you handle all of these situations in one fell swoop. This is really recommended from an architecture perspective. It also handles the case where you can programmatically trigger a restart of your activity manually. All of those will work. But there's another situation. If you just handle these, you get most of the activity recreations for you. Those get handled. But if you listen to reports from your customers and possibly from the Google Play Store, you might hear reports of this. So you might hear users saying, I was doing something really important in the application, and then I went to look something up, and by the time I came back, all of the state was lost, and I've been working on that for hours. So what happened? And that's because there's another reason that the activity can be recreated, and there's a whole other world to what's happening here, because there are scenarios where your view models, singletons, and static variables can all get wiped out and reinitialized, even if the user doesn't leave your application. And that takes us into another category of activity restarts, which is process eviction. And these behave a little bit differently. So to dive into this, there's a few reasons that Android will recreate your process. It does these. The most well-known one is low memory. But the goal here is that Android should be able to kick your process from memory, and it should be able to restore it so that if the user does want to come back to it, they can do that, hopefully without noticing that anything has happened. There might be some more delay when your application is reloading and bringing everything into memory, but you should be able to return to that old state. And the other thing about this is when Android kills your process, it's doing so very forcibly. It's not going to call on destroy for you. It's just going to do it. The primary way that we know that Android will do this is with something called the Viking killer by a few people at Google and also by me, because that's a fantastic name. More formally, it's known as LMKD, which is the low memory killer daemon. The behavior varies device to device, but basically the way that it works is if there's significant memory pressure, so you're running like Google Chrome in a video game or something, then eventually the system is going to need to reclaim memory to keep things working. And what it'll do is it'll go through applications that are in the background, it'll find ones that are least recently used, and it will evict them out of memory and keep their states. So what that means is if you wrote to your on-save instance state bundle, that bundle will get persisted and Android will use that to recreate your process later. And hopefully users don't know that this is happening at all. The less common reason that your process can restart actually relates to permissions, because we have callbacks in place to tell when our application is granted permissions. We need to do those to show that dialog and respond to those results. But we don't have a callback for when a user revokes permissions. The way that Android actually implements that is to kill the process and then recreate it. Because when we recreate it, we have to go and check all of those permissions again. And that's the only really guaranteed way that the framework has to make sure that we're not doing anything badly. In practice, this does behave the exact same way as the Viking killer, but it does also mean that you might be making an incorrect assumption that just because you checked for permissions before launching an activity or fragment means that when the fragment or activity is started or created, that it has those permissions. That might not be accurate if you've revoked a permission while you were on that screen. Another thing that I do want to call out is that there is a force stop button on the app info page for every application, and this has nothing to do with anything that I've just talked about. It's completely different. The way that this button works is if the application is running, it will evict the process immediately, but it also throws out all the save instance state bundle. So you can't use this as a way to test how your process deaths are working. So this raises the obvious question of if that button doesn't work, then how do I test this? And there's two really good ways of testing this. One is you can do this with Android Studio. So if you run your app in Android Studio, you can leave the application, hit the stop button, and then reopen it on the device, and that triggers the same scenarios. There is also a library called Venom, which I did not make. It will do the exact same thing, and it will give you a notification to do this. If you're using view model, the way that you can handle this is to implement the save state library. So at this point, if this is an issue to you, you will probably want to start talking your team into using this. And at this point, your Android manifest only has one really attribute for your activity tag, which is really clean. And the rest of your changes are going to take place in your view model. So if you have this counter view model from before, then you'll update it to look something like this. So the changes here are you'll take a save state handle into the constructor of the view model, and then whenever you modify the counter value, you will write that to the save state handle as well as mutating whatever live data you might have associated with it. And then when you want to initialize things, you can either read the value as it was last saved, or you can create a live data that has that value by using the get live data function on the save state handle. If you don't want to use view model or save state library, I do want to call out that you can also use on save instance state, and this will also work perfectly fine. So if you have stronger opinions about architecture and you don't want to use those libraries, you can do that too. It will work just fine. And at this point, we are handling everything now. And depending on where you are, you might have a lot of things that you need to update if you're concerned about these things. And at this point, you might be thinking, well, okay, at least you're not going to tell me anything drastic. Like, this is all doable, but it's still a lot. And I have some bad news, because you also might be making assumptions about your initialization logic executing as you expect. And this doesn't always work. And there's two ways that I'm going to talk about this. The first one is your splash screen. You might have an activity that looks something like this. So when you launch the application, you can show some screen that has a logo associated with your application, and you can do whatever prefetching work that you might need to do before you can actually launch your UI. You'll then launch the activity for whatever your main activity is to show all the content. And then you don't want users getting back to that splash activity, so you'll call finish on it to get it out of the backstack. And at this point, the initialization has worked perfectly fine. All of our data is where it needs to be. The problem comes when we're being restored from process death. Because when Android is restoring our application from process step, it only restores activities that are on the backstack. And because the splash screen isn't there, it means that any initialization logic that we did there has not happened this time. And if you're doing things like setting up singletons or even like setting up Dagger, for example, in your splash screen for some reason, then this can lead to a lot of exceptions because your application isn't in an initialized state that you expect it to be. There's also another edge case that is very bad. Let's talk about your application class. A lot of people have initialization logic, especially for Dagger, living in your onCreate method of an application class. And there is an edge case, very rare, but it can happen, where this never gets called. If you look in your bug tracker, you might actually see an exception where your application can't be cast to whatever type you specify. And if you're running in the debugger when this happened, you would actually see that your application class isn't an instance of whatever application class you specified it as. And this is going to be a really insane thing to see, and it seems very impossible. So the first thing that you'll do, of course, is you'll go into your Android manifest and you'll say, no, I did specify that the application should be this class. And we need to talk more about what's happening here to really understand the full details. Because if you look at what the application class is, you'll see that it's the base class. And this happens, to my knowledge, in exactly one situation, and it has to do with backups. Because if your application is being backed up or restored, then it gets initialized in sort of a sandboxed mode. The goal here is, because there's a lot of initialization that involves disk writing, it's very easy to initialize the entire universe. Your application is initialized in a very basic mode where the application class isn't used, it uses the base instance instead. Your content providers are not initialized, but your users can still launch activities. So if this happens and your users go into your application, then you can actually skip all of your activity or all of your applications on create logic. And sometimes this will happen after users have first downloaded the application. So it's possible that the first experience that they see is your application crashing. This is very upsetting. This is very bad news to hear. And you might want me to tell you right now how to fix this. And it's a little bit awkward. So my first advice here is see if your users are affected by this. If you don't allow backup, then this probably isn't an issue for you. Also, if this doesn't affect that many users, then you probably don't want to bother. But if this does affect users, then there isn't really that good of an answer to this, unfortunately. The most clever thing that I've seen somebody do to this is they've, in their initial activity, they've checked whether or not their application is theirs. And if it isn't, they just show a dialog that says, we can't start the application right now. And then they just close the application and eventually they'll be able to start it. This does work. It is awkward and ideally the framework would handle it for you. But this is really as good as you can get with a lot of the initialization logic. At this point, we've made a lot of really good progress here. We've handled a lot of different recreation and death scenarios and even some really obscure crashes. But because we're spending a lot of time fixing these, our product manager is coming to us and they're very upset because they need features. That's where the company is making money from. So we're going to talk again to our designer because our designer wants us to add a details page to some component in our activity. In this case, the example that I'm going to go over is a list of students. So you might have some student lists and you want to open a student detail fragment to see all sorts of information about them. This is really common. One classic way of implementing this navigation is to use a new instance method that looks something like this. You can take your student, you can implement parseable on it. There's a parcelize annotation to do all that implementation for you, which is really great. If you don't want to do it manually and you're using the navigation library, then it will look something like this, which is also very clean. The problem with using an argument, it applies to both of these, is really what we're passing in here. So in this case, the student object itself, because universities have a lot of information about their students, it might be a very, very large object, and it might be really big. This can cause a few issues, especially if you're assuming that the student doesn't change between the time that you start the new UI and by the time that you commit the changes. You might assume that the student won't change there and you might not observe it, which is up to you to decide whether or not that's good or bad. But really, there's a couple of things going on here. And The first one here is if you're not using either of those two implementations, if you're not using bundles or the navigation library, you might be making a mistake where if you're using a property or a constructor, then you might not be actually persisting those values correctly. And if you get a configuration change, you might lose that parameter entirely. So that's its own issue if you're not handling that. But the real issue that I want to call out here is that there's more restrictions than just the type of data that we can fit inside of a bundle. So we know that there's limitations on using primitive types, parseable, serializable, and all of those. But right now, we've got a very big parseable, and there's actually a size limitation. So we need to be mindful of that. The code that we've got is okay-ish, probably. We're not going to run into that limit. But if we start doing something like this, where you're using serializable, that takes up more space because it's a less efficient persistence mechanism. But the worst possible thing that you can do as far as size is concerned is to use JSON instead. This is going to be very large, and I do not recommend that you do this under virtually any circumstance, because there's a very small limit for how much information can be stored inside of a bundle. At most, and this is a very theoretical limit, it's 1 megabyte. This is the amount of memory that Android can transfer between processes, which needs to happen because this information needs to go from your application into the activity manager for your activities to be started and for the state to be persisted. You also only get 1 bundle per activity in terms of saved state. So this does apply to both when you are doing fragment arguments, intent extras, and saved instance state bundles. So with saved instance state bundles in particular, you only get 1 of these for a specific activity, which means that you need to be careful about all of your fragments contributing against this limit. And the official recommendation is to keep all of this state under 50 kilobytes, which is not that large. So the goal here is to avoid complicated objects and don't use JSON, because it's very easy to get like a 3 megabyte JSON file, which will never fit into one of these bundles. In terms of saved instance state in particular, it might look something like this. This is extremely exaggerated because there's more state than just the state that you are persisting. There's also the internal state, like your view state, your fragment backstack, and any fragment arguments that they have. And for a single activity, those all get combined into a single bundle. So if you're using something like a parseable, that will contribute a lot if it's a very complicated object. But if you're using a JSON string, that can easily exceed this limit, and you don't want to do that. So instead of passing all those values, you should be very careful and mindful about what you're passing and persisting. Realistically, the type of information that you want to be storing either for arguments or for saved instance state is state. So it's things like user input. It's anything that you can't derive later on. If you have an object that you want to display, consider passing the ID instead of the entire object itself. And if you do need to pass the entire object, then definitely don't use JSON, use parseable if you can. So that's all great. We've now got this navigation working. We've implemented that feature, everything is good. And then our designer wants us to implement some retry because we might have some errors that are network related inside of our application, and we don't want to handle those gracefully. The first thing that you might consider doing in this situation is to use an alert dialog. The downside to an alert dialog is that as soon as you rotate the phone or do any other configuration change or any other activity recreation, that dialog is going to go away. So this isn't really going to work out. Another thing that you might want to do is you might want to use a dialog fragment, but you might want to use a really generic interface. And I see a lot of people trying to use Lambda expressions with dialog fragments. The issue here is that there's not a way to persist Lambda expressions. So here I'm using put parseable in order to store this Lambda expression, but that's very questionable because Lambda expressions aren't parcelable. If you actually were to try and do this, then it would be a compiler error in that situation. Or if you're using the navigation library, then you get one of 2 errors. The first one, if you use the Lambda type, is that it's just not a legal identifier. But the other error that you might get is runtime, because it doesn't implement either parseable or serializable if you pull out an interface instead. And really, there's not a way to use Lambda expressions with fragments effectively whatsoever. Because the Lambda expression can capture any part of an activity, you might be trying to persist that entire activity, which at best leaks the activity, at worst does a whole lot of other really nefarious things behind the scenes. But really, you're going to lose this information as soon as you get a configuration change, and you want to avoid it. So instead of going those routes, you should use a dialog fragment instead, and you can use a view model in order to send those results. So here we've got the dialog fragment from before. We're getting an activity view model specifically because if you get one that's scoped to the fragment, then it'll go away after the dialog fragment disappears, which you probably don't want. So here we're setting the positive button to just retry some photo upload that may have failed and may have caused this dialog to reappear. An alternative option, if you don't want to use a view model, is to use a callbacks interface. So here I've added an interface that has an onRetryUpload function, and you can just require that the activity implement this callbacks interface and delegate the behavior somewhere else. And this is all fine, and you roll this out and it's working. And then you also notice that your crash reporter has illegal state exceptions complaining about when you're showing this dialog. And there's another assumption that's made here about being able to show fragments and do transactions arbitrarily. And this also is not true. The reason, or one reason, that this might not be working is because in this case, you might be uploading a photo, and then suppose you get a call from your mother. And you're a good son or daughter, and you know that it's in your best interest to answer this phone call. So you go ahead, you answer the call, you have a lovely conversation. But in the background, your photo is still being uploaded. Your activity has been suspended, and it's still doing that upload, and it's still churning along. If you get a network error in this state and you are using that to show a dialog, then that's where the problem is. The problem here is because your activity is in the stop state at this point, you can no longer do fragment transactions because there's a possibility that this activity gets evicted from memory and needs to be restored after process death. And there's no way to modify the bundle of save state that you've already persisted. So the fragment manager makes it illegal to do fragment transactions while you are in the background for this reason, because you might not come back to them. I do also want to point out that this isn't exclusive to phone calls. If your activity is in the stop state at all, then it's illegal to do fragment transactions. And if you're using the navigation library, then you might not even know that this is an issue, because when I was testing it on, I believe, a beta version of the library, it actually swallows the error and just logs into logcat that we can't do this navigation call. So you don't get an exception, and you also don't get the navigation, but you don't get a crash, which is good. If you really do want to show this dialog because it's important, though, then there's a few options. The one that I've seen a lot of people use is to use commit allowing state loss instead. The way that this works is it does allow you to do the fragment transaction while your activity is in the stop state, but it does mean that if your process gets evicted and the user comes back to it, then you might not see that dialog, which might be okay because that's a really rare situation. And with this dialog in particular, it's just related to an error. So the user will probably see that their photo isn't being uploaded anymore, and they'll be able to make sense of what happened. So this is one approach to handling it. If you have a more advanced dialog where you do need to make sure that it always shows, this can range from really difficult to impossible. And you need to be really careful about how you're thinking about how you do that. And at this point, I've given you a lot of information and pointed out a lot of things, and you may be wondering, well, okay, can I go ahead and fix those right now, please? And you may also be wondering, how do I do that? And really the advice that I have here is to do the right thing for your application. And I will leave you with one parting assumption, which is that you have to fix every single one of these problems, which might not be the case for your application. There's a few exceptions to this. For example, if you're not publishing your application, or if you have an application that you haven't uploaded, that you haven't updated in 7 years and it's designed for like Android 2.3, it probably doesn't matter if you've had these problems anymore. At this point, there's not really anybody using your application, and it probably doesn't matter that much anymore. Likewise, if you're doing a demo library or you have some other toy application just to demonstrate some functionality, and that functionality doesn't rely on process death or configuration changes, it might not matter if you're not handling these. Another really big reason that I see people not handling these, which actually works out ironically well, is if they're running on controlled hardware. So what I mean by that is if you are building something for a kiosk or like a smart refrigerator or something, and you are running your software on that, then you probably know that you're not going to have to worry about rotating from portrait to landscape. Like if your refrigerator is running in landscape all of a sudden, you have a very big problem, and it's not that you lost activity state. Another big reason that you might not need to handle this is if you're doing something with a game engine, for example. So if you're working with like Unity or some other 3D engine, you don't want to really recreate your entire activity because that can introduce latency if you are in some really intensive situation and you do want to handle orientation changes. So you might use config changes if you are a game engine to prevent a scenario where your game stutters for a second and then comes back to life. There's a few other exceptions that you can think of to justify these behaviors, but if these aren't you, then please proceed. First of all, please embrace activity and fragment transactions. They're a reality. They're going to happen at some point or another, especially if you have a lot of users that have downloaded your app from the Play Store. And you can effectively think that an activity recreation can happen virtually anytime. To fix these, or really to implement these correctly, use viewModel and save state, or override on save instance state and use that saved instance state bundle to maintain this state. You can try to avoid Android configuration changes, but there are a couple of exceptions to this rule as well. For example, WebView does not support writing its state into a bundle. It used to, but that was actually leaking disk space. So in all modern versions of Android, that's disabled. So if you're using WebView and you want to support orientation changes, you might add config changes for window size in that example, and just let your activity restart and lose state if you change languages or something. Likewise, if you're doing something with surface view, so something like a game engine or possibly using the camera, you might not want to recreate your activity because that can introduce latency and stuttering, which you might want to avoid. So there are a few exceptions to when you can use config changes, but please don't throw it on every single activity in your application because that's not a good idea. The other thing to be mindful of and to tolerate is process eviction. So make sure that any initialization logic that you have on your splash screen isn't critical for your application. So don't do things that will lead to things like null pointer exceptions or illegal state exceptions. Do lazy initialization if you can. Also assume that if you are in the middle of a complicated flow, there might be a situation where the user leaves your app and comes back to it, and all of the state that existed in singletons has been lost. So you need to make sure that anything from a more complicated flow is being saved somewhere like a save state handle or in a save instance state bundle. And likewise, prefer lazy initialization, lazy loading, if it's possible to do. A lot of the time, this isn't possible to do with things like frameworks like bug reporters and other third-party APIs that you might be integrating with. And for those, it's safe enough to leave those in your application class. And if you really need to tolerate the backup situation, to do that on a case-by-case basis. The last words of wisdom that I have are to make sure that you are testing these scenarios to make sure that you are doing what is right for your application. If you have your app locked to portrait, trigger uncommon activity recreation scenarios. Do things like change your display size, change your language, change your locale. If you, like trigger multi-window, run it on a foldable phone, make sure everything is working. Trigger process death using Android Studio or using the Venom library. And don't rely on the don't keep activities toggle in the developer options to test this for you, because it's not a real world representation of what actually happens. Don't keep activities will destroy activities as soon as the user leaves them, which isn't true. If your activity is on the backstack, it will be in the stop state. It won't be destroyed yet. Don't keep activities also does nothing to simulate process death, so be very mindful about that if you've been using it to test activity recreation scenarios in your application. And again, I cannot stress this enough. Fix the problems that affect your application and your users, because there is not a one-size-fits-all solution for these issues. Thank you so much for listening. I've been Andrew Bailey. You can find all of this information. I'll have a link to this recording as well at andrewbailey.dev/falsehoods, where I've got right now some additional information, a link to that Venom library, and also some more resources if you want to investigate these crashes for yourself. And now I believe we can turn it over to Q&A.
Yes, we can. Thank you so much for the amazing talk, Andrew. I sure learned a lot. We have a couple of questions, and I'm gonna hand it over to Jan so we can get those right away. Just give me 1 second here.
Yeah.
So Jan should be able to present his screen now. And there we go.
All right, let's see, going top to bottom, is it also possible to use ADB to kill and recreate app processes? You probably can. I'm not sure what that would look like, but I'm guessing what it would be is you would run the application, leave it by hitting the home button to make sure that you're saving the instance state, and then use ADB to kill the process. You might also be able to use some task killers in order to accomplish that. Let's see. Is don't keep activities in the developer options a good tool to test these state changes? I think I just mentioned that, but it will not do process if. It won't trigger that whatsoever. It's not attempting to do that. Will you share your slides? I'm not planning to upload the slides, but you can rewatch this presentation again. I do also have a cheat sheet that does a really good job of summarizing all this information on that andrewbailey.dev/falsehood site. So check that out. I think that'll be really helpful. What is the best way to test these various configuration changes, preferably using Espresso or UI Automator? That's a really great question. Oh, I think I'm hearing myself. So one thing that you can do is you can use, there's a testing library called Activity Scenario. You can actually use that to trigger entire recreations of your application, or of your activity rather. So if you wanted to do that, you can do that, and that would simulate configuration changes. Another option is you can literally rotate the phone. You can change the requested orientation of the activity, which will also trigger a configuration change. When the process is destroyed and recreated, does the Android platform maintain the process activity / backstack? Yeah, the backstack records themselves are all maintained. Activity Manager saves those out to disk. So the backstack itself is persisted. That's where those save instance state bundles live. But nothing from your application process at that point could be alive anymore. Which implementation do you recommend to prevent these issues if you are using MVP? Oh, that's a great question. I don't personally use MVP. I use MVVM and I use ViewModel personally. My recommendation would be to, if you're not using the ViewModel library, would be to write some sort of abstraction or some sort of method that will expose the saved instance state bundle, and then override on saved instance state, delegate that over to your, I guess, presenter probably, and use that to write into that bundle and then save the state. What happens if the bundle limit size is exceeded? I'm so glad you asked. I forgot to mention this during the talk. It depends on OS version. If you're running on Android 7 or higher, then you will get a transaction too large exception, and that will get thrown at the time of when you start the activity or save your instance state. It doesn't happen when you exceed the size of the bundle itself. The bundle doesn't actually have a size limitation. If you're running on an older version of Android, pre-7, then you'll only get a log that goes out to the console, and I believe that the activity just doesn't start, which is very confusing and unexpected. Clap, thank you so much. Let's see. What happens if the bundle limit size? We talked about that. Why can you use lambdas in Material Alert Dialog Builder? Does it suffer from this issue too? I haven't used Material Alert Dialog Builder itself, but I'm guessing that this is more attuned to Alert Dialog. I'm guessing that if you show this and then rotate the phone, that dialog will disappear. You can use Lambda expressions with Alert Dialog and with a Material Alert or some other dialog itself, but as soon as you pass those into a fragment, that's where you will get issues. What is the best way to mimic a foreground service being killed by the operating system, and how do you make sure to restart it every time? Let's see, foreground services, I'm not too familiar on how you could trigger death from them, especially because from my experience, the operating system can seemingly decide to kill those at random, especially on poorly behaving devices like Samsung with a lot of background restrictions. So I don't really have too much advice for that. I'm guessing you could probably just terminate your process if you look up its process ID, and you can send that, basically implementing a task killer if you wanted to do that from a testing scenario. Can you describe why we should not use live data inside a repository in MVVM or MVI architecture? Let's see, live data itself in a repository, I don't disagree with. The main thing to be concerned about is if you are using live data inside of a repository, you might have state there that doesn't get persisted. So if you're relying on a repository to be in a particular state, then that might not be true, because when you're coming back from process death, those repositories will get reinitialized and won't contain their values anymore. So that's the only reason why you wouldn't want to do that. Otherwise, I'm not really trying to give an opinion on like live data versus RxJava or coroutines inside of your repository. Do whatever is right for you. Let's see, you spoke about testing activity recreation. Is there any reasonable way to test process death? To my knowledge, I'm not aware of a way of like unit testing process death. It gets very complicated because there's a sort of intricate relationship between the test runner itself and your application process. I would love to look into this more, because I'm thinking that because of a side project that I'm working on, this will be relevant. But I don't know of a good way of testing this apart from doing that manually. If you are doing that manually, then run through the steps in either Android Studio or use Venom or another library that can trigger process it for you. The practical bundle size limit is 500 kilobytes. I'm pretty sure it's 50 kilobytes. I could be wrong on that, but the link that I have, the andrewbailey.dev/falsehoods, I do have a link to where Google is suggesting that you keep your state under 50 kilobytes. So that is an official recommendation from Google. Let's see, transaction 2 large exception, we talked about that. Before making the fragment transaction, how can I check if the state is saved? Oh, that's another great question, because I've seen people do this as well. I don't remember if there's an API that exists in the activity library or in the activity framework that will do this for you. What I've seen people do in the past is to keep a variable and to basically say, like, is instance state saved, set it to, set it to like true initially, set it to false when you are on creating your activity, because that save instance state is being restored out, and then update it again when you are writing that instance state out, and basically keeping track of it manually. I wish there was a better way of doing that, but I'm not sure if there is off the top of my head. Some other scenarios where on-save instance crash can occur. I'm not sure what this question is getting at. I definitely covered the main situations for crashes. I think there's a lot of other reasons, like this barely scratches the surface, and there's a lot of other ways to do things incorrectly. So if you're not doing best practices, then you could be running into your own crashes that I haven't seen if you're doing some more obscure implementations. But sure, there's all sorts of other reasons why crashes could occur that are related to saving instance states.